Okay, guys, so today, as she had stated, I'm going to be taking over and teaching you guys. Best behavior and participation, please. Thank you. Okay, go ahead. I will share my screen, I suppose, but we are going to do the reading guide, and I'll kind of walk you through that. And from there, let's see. So go ahead and go to modules. Can you guys see my screen okay?
Yes.
Okay. And you're going to hit the 3.3.1 study and reading guide. Let me know once you guys are all there. Perfect. Thank you, Chris. Thank you, Catherine. Thank you, Evan. Thank you, Lucas. Perfect. Thank you, Sevilla. Logan, Ureli, are you guys there? Okay, cool. So I wanted to start off by, before we even begin this reading study guide, just going over some definitions, some words that you're going to see in this reading guide, just to make sure we have complete understanding so it's easier to get through it. Hey, Sam, how are you? Go ahead and open up the 3.3.1 reading guide. It should be under modules. So, a few of the words I wanted to go over today were like inertia, what you guys think applied force is versus like a friction force, like mass, words like that, just so that we have total understanding. So, you guys can go ahead and just shout it out, but does anybody have a definition for inertia? Or like a funny saying that we always have had to remember it?
I
Yeah.
think it's different, like, change.
What was
Like,
that?
it's another with motion.
Okay. Do you guys agree or disagree? What about Sevilla? Yes.
I agree.
Okay. So, inertia, it's kind of like the lazy teenager, right? Like you don't want to change its state of being. So, inertia would be a matter of like resistance to a degree. Like you don't want to change the state of being, the lazy teenager. What about mass? Do you guys know how to explain mass?
Mass is like how much space matter takes up.
Yes, perfect. So matter. It's all about matter. Hi, Sayla. We are opening up the 3.3.1 study reading guide. It should be under modules, all right? What about applied force? What do you guys think of that? Can someone tell me like the difference between applied force and friction force?
Isn't the difference between applied force when like you do it yourself, like you actually are doing pushing it yourself, and friction, it's kind of already just doing it on its own because the car, say like a car's moving, then it like it's trying to stop it, kind of will slow it down technically because of the friction between the wheels and the floor.
Yeah. So it's sort of like, let's say a couch, for example. So, like, applied friction would be you pushing the couch, and the friction force would be like the ground or the carpet or whatever it's touching, sliding up against it, causing kind of like a resistance almost. And in order for an object to move, your force has to be greater than the friction. Okay? So So we're going to go ahead and dive right into this reading guide. Make sure, for those of you who are just joining us, that you go under modules and pull up the 3.1 study reading guide. We are going to go through this reading guide. You guys will do the review and check up on your own independently, and then in the last 5 minutes of class, we're going to kind of come back together because there is a discussion board that I want you guys to have a chance to complete with me here in case you have questions. Okay, so main idea, matter resists changes in its state of motion. So Newton's first law of motion has 3 main points. Also, make sure that you guys make a copy of this so you can type on here and highlight if you need, okay? Identify the statement below that states the reason for a change in an object's motion. So, seeing this right here, do you guys have any ideas? Newton's first law. Identify the statement below that states the reason for a change in an object's motion. And you can just shout it out. Lucas G, do you know the answer to this one? Do you have a guess?
Newton's first law of motion has 2 parts.
So the reason for a change in an object's motion.
I think it's
Do you need help?
Yeah, I think so.
Okay, let's walk through this. So a stationary object resists any change in its motion. Stationary is something that's just sitting there. It's still. So if we are looking at Newton's first law of motion, let's go back here. Objects at rest will stay at rest, and objects in motion will stay in motion at the same velocity, unless acted upon by an unbalanced force. So it can't be the first one. An object in motion resists any change in its motion unless there was an unbalanced force, which is true, but that's not the answer we're looking for because we're looking for the reason for a change in an object's motion. So that would have to leave us with this one right here. A non-zero net force causes an object's state of motion to change. Okay? So make sure you guys highlight that one. Does that make sense? Do you guys have any questions on that? Good to go? Okay. Number 2, choose the correct words to complete the sentence below and delete the one that does not, or you could highlight the correct one. The reason the letter M represents both mass and inertia is that matter has what? What did we just say mass is?
Matter.
Exactly. So matter has mass, but because of its mass or inertia. In this case, it's going to kind of be backwards. So the reason the letter M represents both mass and inertia is that matter has inertia, a resistance to change because of its mass. Does that make sense to you guys? So the heavier an object is, the harder it is going to fight to be moved. When you apply a force to it, it's going to have a lot stronger state of inertia. The lighter something is, the less inertia it will have. It's going to be so easy to throw it, shove it, push it, move it around, whichever. Does that make sense? Okay. Make sure you guys are highlighting your answers here because these are notes that you can use on the quiz. We do have a quiz on Monday, so make sure you guys are taking notes. You'll want these notes. So, main idea, applying an unbalanced force to an object causes a change in the speed or direction of its motion. So, the arrow on the right represents a force applied to a heavy object, the car. Describe how you could change this diagram to show balanced forces. So go ahead, you can shout it out. What do you think we should do to make this image right here balanced?
You can push it equal amount of force. You can push it with like a more amount of force at least.
Could you speak a little bit louder, please?
You can push the car with with an equal amount of force, or at least like a similar one.
Right.
'Cause,
What side though? Would we put it on this side or this side?
the back of it, because we want to push it. The back of it, because we want to push it forward.
Do you guys disagree or do you agree?
I agree.
Does anybody else agree or disagree? Isaac?
I agree.
I agree.
Okay. So go ahead, in your own words, you guys in the box here, you will want to type, describe how you could change this diagram to show balanced forces. Let me know, give me a thumbs up once you're done with that, and we will move on to the next one.
Where do I go?
Hi Levi, so go under modules and you'll want to open up 3.3.1, the reading guide, and that's where we are at right now. Let me know once you guys are done typing there. Give me a thumbs up or put it in the chat. Yeah, Luke.
I can't highlight it.
Did you make a copy of it when you opened it?
Oh,
Yes, make
No,
sure you make
okay,
a copy
yeah.
or else you guys can't edit it.
okay.
Are we almost done? Perfect. Thank you, Sophia. Thank you, Evan. Thank you, Chris. Thank you, Catherine. Isaac Serratos, why is your camera off? Can you please turn that on? Same for you, Levi. Thank you, Luke. Levi, is your camera not working?
Yes, sir.
Okay. Thank you, Sam. All right, we're going to go ahead and move along.
Mr. Rios?
Yeah, Isaac? You're muted. I can't hear you.
Oh, I'm making a copy still because it's taking a long time to load.
Okay. If you have like a notebook and pen, maybe write it down in the notebook so that way that once you have a copy made, you can go in and change it. Okay. Number 4, identify the words that correctly complete each sentence about static friction. Choose the correct words to complete the sentences below and delete the ones that do not. Static friction is a mass or force that acts between touching or separated surfaces and opposes or causes motion. What do you guys think for this one? Static friction is a mass or force?
Force.
Force that acts between touching or separated surfaces.
Touching.
Okay. And does it oppose or cause motion?
Pose.
Anyone else? Oppose or causes motion?
Causes.
Causes.
Why do you think it causes? Can you explain how you got that answer? Or are you just guessing? Isaac, Catherine, do you guys know why you think it would be causing motion, or are you just throwing out a guess?
I saw it in my notes once, so I think that's where I'm getting it from, but I'll look again.
Okay, let me tell you guys. So static friction is a force that acts between touching surfaces, and it actually opposes motion. So it's kind of like how I explained earlier in class today. If you have a couch and it's on the floor, so you pushing the couch is your applied force. The friction would be the floor or something in between that's touching on the couch that's causing it to resist to move. Therefore, in order for something to move, your applied force has to be greater than the friction. Static friction changes in size or stays the same when the size of the force acting against it changes. What do you guys think for this one?
I think that it stays the same.
Okay.
I think it stays the same.
Anyone else? Okay, so actually, this one can be kind of tricky. You would think that it would just stay the same, that it shouldn't change, right? But actually, the static friction can sometimes change in size when you're pushing a certain applied force. Kind of confusing as to why. However, the static friction does sometimes change in size when the size of the force acting against it changes. When an applied force or force of friction does not cause a sofa to move, the two forces are balanced or unbalanced. So, what type of force does not cause a sofa to move?
Balance.
We're up here. Applied force or force of friction does not cause a sofa to move. Remember the example I used earlier?
Oh, okay. Sorry.
Oh no, you're fine.
When a force of friction.
Yes, perfect. So when a force of friction does not cause a sofa to move, the two forces are balanced or unbalanced?
Balanced.
Balanced.
Yeah, perfect. Good job, you guys. The sofa will move only when the applied force or the force of friction becomes greater than the applied force or force of friction. So, which one is this? Is it applied force or force of friction?
Applied force.
Yeah, so the sofa will only move when the applied force becomes greater than the, which one?
Force of friction.
Force of friction.
Yeah. Perfect. Good job, guys. All right, number 5. We're making progress. Complete the chart to summarize the example involving a cat and a fishbowl. The maximum force of static friction between the bowl and the countertop is 38. What do you guys think for this table here? So if the force of the cat is at 10 and the friction force is at 10, will the fishbowl move?
This is a trick question. They won't move because it's left or right. So they won't move.
Yeah, so they're left, they're right, and they're the exact same amount of force. Therefore, they will not move. It's balanced. It's completely balanced. Right here, we have a second one that says the force of the cat is 30. The friction force is left blank, but it does tell us that the fishbowl will not move. So what would the friction force have to be in order for nothing to move at all, for it to be balanced?
$30 newtons, right?
Do you guys agree, or do you disagree?
I agree.
I agree.
Okay, yeah, so it should be 30 newtons right. So that way that is completely balanced. This one is left blank entirely. The force of the cat is 50 newtons left, and the maximum force of static friction between the bowl and the countertop is 38 newtons. So you guys can fill in the blank here, and there is only a few more after this for you guys to complete. So go ahead and try to complete as much of this the rest of the way on your own as possible. If you guys need any help at all, you can ask. You will want to finish this and go into your review and checkup. We will come back, let me see here, when does class let out? At 9:38. So we will come back at about 9:30 and we will go ahead and start the discussion board. Whatever you guys don't get done in class, you can do for homework, okay? Before class tomorrow. So go ahead and work independently, and if you need help, reach out to me, okay?
Mr. Rios?
Yes, Isaac.
I have a question on some of the answers because like I wasn't here for most of it, but
Okay, yeah, what are your questions?
here, where is it? I have a question for the number 1 and number 2.
Let me go there.
Yeah.
What are your questions?
I'm confused on the first 3. Like number 1.
Oh, okay, yeah. So Newton's first law of motion has 3 main parts. Identify the statement below that states the reason for a change in an object's motion. So we went back and we reviewed Newton's first law. So objects at rest will stay at rest, objects in motion will stay in motion, unless they are acted upon by an unbalanced force. Therefore, which one of these appears to be an unbalanced force? Which one of the 3 here? If an object is stationary and resists any change in motion, that's not a force, right? That's not like an
Yeah.
unbalanced applied force. An object in
That's-
motion. What was that, Isaac?
The first one was balanced.
Right. An object in motion resists any change in its motion. That is also balanced. Therefore, a non-zero net force causes an object's state of motion to change. Does that make sense?
Yeah.
Okay.
So should I type like on the side of it?
You can highlight it, you can put a little star by it, whatever you want, so that you know that that is the correct answer.
I'm gonna highlight it yellow.
Okay, perfect. Do you need help with anything else, or was that it?
Yeah. Number 2.
Okay, yeah. So the reason the letter M represents both mass and inertia is that matter has blank because of its blank. So can you tell me what mass is?
Here, I have it in my notes like the correct definitions. Oh, I don't have mass in this.
Okay.
Uh,
So mass is basically matter, okay? And so right here when it says both mass and inertia is that matter has blank because of its blank. What is inertia? Do you remember?
inertia is like the rule of like a teenager.
Yeah, perfect. So resistance, right? You want to just stay doing what you're doing. So if something has more mass and more matter, more density to it, would the inertia be less or more?
I think more.
Yeah. So the reason the letter M represents both mass and inertia is that inertia, or that matter has inertia because of its mass. Does that make sense? The more mass, the more heavier something is, the more it's going to resist. Whereas the lighter something is, the less it will resist. The easier it's going to be to move that.
Oh, okay.
Does that make sense?
Yeah.
Okay.
Miss Rios.
Yes, Evan?
For question six, it says watch the video of the skateboarder, but I don't see any video.
So are you in Apex by chance? You'll want to be in Apex doing this.
Okay.
If we can't find the video, I will go out on a hunt for it and see if we can find it. Also, guys, for number 3 on here, I am sorry, let me just correct you. For the applying an unbalanced force to an object, for the car here, when the arrow is pointing to the right on the car, in order to make that balanced, you are going to want to put something on the other side of the car, okay? The object, it will cause a change in its speed or direction of motion. In order to balance that out, you're going to want to put something on the opposite side of the car, okay? That will then create to where it is balanced. It will not be in motion. It should be still. Make sure you guys put that for number 3, okay?
You mean write it down or put it in the picture?
You'll want to write it, explain how you can change the diagram to make it a balanced force. So right now with the 1 arrow, it will change its speed. It most likely will go even faster. It could change directions, whichever. So in order to make it balanced, you're going to want to put something on the other side of it as well. Does that make sense?
Yeah.
Okay.